Today we're going to look at a new function. It's called the exponential function, which you read about last night. This lesson we're going to learn how to identify and graph exponential functions. As a little warm-up, we're going to see how well you read about your exponential functions last night. Let's say Joe owes 25 cents to the Lent Fund. He forgot to pay for 5 days. As you know, the interest rate is 10% per day. Pretty steep. So how much does Joe now owe? Put the video on pause and calculate the answer, please. As you know from your reading last night, the standard form of an exponential equation is y equals a beginning amount times b, the growth factor, raised to the power of x, the number of time periods. So for this equation, we have what Joe owes, the y value, is equal to his beginning debt, 25 cents, times the growth factor. So at 10% interest, the growth factor is 1 plus 10%. And all of that gets raised to the power of the time period, which is 5 days. We put that into our calculator. We get y equals 40.2628. Of course, we'll round that out to the nearest cent, which would be 40 cents. So, Joe, time to pay your debts. So to understand the big idea of this new function, the exponential growth function, we want to go back and revisit some of the other functions we've learned and key ideas. See if you can list in the first column some of the key ideas you've learned about functions. And over the top row, try to put in some of the main functions that we've learned. Put your video on pause and fill out as much as you can think of, then come back. Here are some of the main ideas that I hope you came up with for our graph, and certainly there's more key ideas than this too that you could have also thought of. Check your work against this graph and see what ideas you can fill in on the grid. So if we look at some of these key ideas, linear equations, as you will remember, the generally used form is y equals mx plus b, not technically the standard form. Quadratic equations, y equals, sorry, that should be an equal sign there, ax squared plus bx plus c. And the exponential form, which we just reviewed, was the y equals a times b to the x. Each of these models of functions have their own parent function, the simplest way you could look at these equations. Parent function for linear is y equals x. For quadratic, y equals the square root of x. And for exponential, y equals, and generally that would be accepted as the y equals 2, simplest number you could come up with, to the power of x. Okay? And finally, we'd want to know the shapes of each graph, and we'd want to be able to anticipate their domain and range.